I will speak slowly, so perhaps the students will also be able to follow the presentation. Basically today, I will talk about a crisis, looming crisis. But people are so much fed up these days about crisis that they just don't want to stomach that there is yet another crisis coming. And the hypothesis of this presentation this afternoon is that this is not only a crisis, but this is going to be the most important crisis for the 21st century. There is a very severe problem which is ahead of us, and Professor Ubertini has mentioned some of the things. I don't want to cause panic, but please fasten your seatbelt, because some of the slides that are coming are equally as dramatic as his. Essentially what we do following his steps is we try to go through hypothesis testing. And the hypothesis is as follows. So far, over the past 6,000 to 8,000 years, it was water that has shaped human civilization. And right now, we are at a turning point when it is the human civilization that is shaping the future of waters. And if we don't do that intelligently, then there will be a positive feedback, and humanity will come to an end as such. I don't want to over-dramatize it. You know, I'm a humble scientist and we don't like to dramatize things. But the message is really very serious. The strong linkage between water and civilization, therefore, is very important to understand. And the story all starts here in the Mediterranean. Some 4,000 years ago, this is in Sumer, where they had an extremely involved system of water management in Nineveh, current Iraq, with irrigation systems, with aqueducti. Or if you go to the neighborhood in Persia, this was the first technology exchange in the history of humanity, when the Persians were tipping, where they were making vertical shafts in order to discharge groundwater from the alluvium down to the edge of the mountain, and that provided water for the people there. And this was also at the same time, this is 3,000 years, when the water law as a principle was born. And this technology with Islam in 622 came to the Maghreb. When the Mozarabs came to Spain, it was called Fogarat at the time in the Maghreb. When it came to Spain, it was called Jalerias. And when the Spaniards went over to Latin America, they took this technology of canal all the way down to Chile. And eastbound, the Chinese route was taken, and in Hokkaido in Japan, you find the same technology for supplying water. Or again in the Mediterranean region, if you look at a 1,000-year-old institution, the Water Tribunal, which even works today, where farmers are settling disputes amongst themselves with respect to sharing water. Water has not even in the old days, but even today, had a great impact on what happens to our heritage, for several reasons. One of them is a climatic variability and change we will come back to talk about. For instance, this is in Thailand. A never experienced flood has flooded a UNESCO site, an ancient Thai temple. And with modern technology, we were able, that Professor Ubertini was also referring to in the case of Rome, we were able to see the propagation of the flood wave and how it will influence the structures. So the question today is, although my first training is engineer, like Professor Ubertini, I'm a square-headed engineer, more and more, as I was moving into the end of my career, I recognized that the important thing here is more than engineering. The important thing here is the cultural setup. We will not be able to turn this land into a sustainable land and world unless we understand the cultural forces, which includes, obviously, history. So therefore, to understand our cultural heritage is a sine qua non to come up with what is called sustainable development. A few years back, in 2015, the General Assembly of the United Nations met in New York, and heads of states and prime ministers have agreed upon a set of goals which, if reached, would make the world sustainable. If these goals are reached by 2030. And there were 17 goals. There were two very important goals, is that by 2030 there will be no more poverty. By 2030 there will be no more hunger. These are extremely ambitious goals, and some say it's unattainable. But if you look at the amount of money and wealth which we have in the world, considering that 80 families own 80% of the wealth in the world, then you start scratching your head that, well, something is not good here. Solidarity is evaporated, and we will not be able to solve these problems unless we change the situation. They haven't made a particular prioritization in the United Nations at the time amongst the UN goals, but I have taken the liberty to propose one theorem that the centerpiece of sustainable development is water. Because if you don't have water, you don't have poverty alleviation. If you don't have enough water, you don't have a solution for the food crisis. If you don't have enough water, you don't have enough energy. So keeping that in mind, and perhaps this is a professional bias for which I have to apologize, but water is the centerpiece of sustainable development. Let us see, to go about how much we have. We have heard this morning that indeed, if you look at all the water resources of the world, 97.5% is salty, marine resource that is not available for human consumption. That leaves us with 2.5% fresh water, of which 60% is in solid state. It's frozen in the Arctic and the Antarctic, in the glaciers, in the snowpack, and in the permafrost in Siberia. Of which what remains, 90% is under the ground, in the shape of a very important resource, groundwater. So what we have at the end of the day, if you compare the available fresh water in rivers, in lakes and reservoirs for immediate human consumption, is a tiny, tiny little fraction of the total. Exactly 0.007% of the total water. In hydrology, this is called the James Bond phenomenon. Because altogether what we have is 41,000 cubic kilometer water. It's a finite resource, and this is the same as it has been at the beginning of the Holocene, 10,000 years ago. 90% of this is in lakes, slow-moving water bodies. So indeed, what we have is a very small quantity, which on top of all is not uniformly distributed. Because if you look at grosso modo, this is just an average figure, while 60% of the population is in Asia, Asia has only 36% of the water available. So there already is a contradiction. Or if you look at Africa, Africa has 11% of the world water resources with 13% of the humans. But Africa is going to face an incredible population growth. So that situation will change. And right now, already in Asia, what we see is a potential of conflicts. Let us see how this is being distributed. This is a figure which I have borrowed from a colleague of ours, Jan Rockström, who published a very thought-provoking paper in the Nature a few years back by trying to establish what he calls the planetary boundaries. The planetary boundaries are defined for certain environmental elements meaning that if we go beyond this limit, then process will become irreversible. And he claims that when it comes to biodiversity loss, the loss of our biological, the diversity of species, he claims that we are beyond the point of no return. When it comes to nutrient flows, he claims that we are beyond the point of no return. When it comes to climate change, he said we are beyond the point of no return. That is to say, things will be getting worse. Now, there are some changes with respect to climate change. It's not as bad, well, it's very bad, but not as bad as he hoped. We still have some hope. It all depends on us. And he said that when it comes to freshwater use, we are fine, because the limit to reach this planetary limit is about 4,000 cubic kilometers annual withdrawal. Where are we? Right there. We are now reaching in about a year time, on the average, but again, this is a steady state figures, grosso modo, 4,000 cubic kilometer freshwater withdrawal. This is very serious. So we cannot postpone this problem to the 22nd century. We have to act now politically. So the question whether, is there really a looming water crisis? Are we beyond that period of easy access to water? I think the answer is, to both directions, is yes. The profession, the hydrology profession, have been shouting so loud about this water crisis coming that even the spy agencies have got the message. This is a publication that was published by the United States National Intelligence Council, which is the CIA and those guys. They are collecting data and then coming up with scenarios. What may happen? What are the global trends which will shape how the world will function by 2030? And they say that amongst the 4 overarching trends which will shape how humans and the world will function, this is not a priority list by all means. They say that the growing nexus, the connection between food security, water security, and energy security is the one that will be a determining factor. And they go so far to say that water may become a more significant source of contention, that is to say, conflict, than energy or minerals out to 2030. Indeed, if you look at the Davos Economic Forum that has discussed the matters and see where we are now 3 years after, they said, and this was the big exodus coming out from Africa, the migration, 2015. So the short-term 16 or 1.5 year ahead scenarios, they were pretty much all right if you look back in the past 3 years. But what they say that for the next 10 years, there will be 5 drivers that will really change how humanity will live on the world. And then they're all water related. Water crisis as such in itself, failure to climate change adaptation or mitigation, extreme weather events, more floods, more droughts, more hurricanes, more all those bad guys, food crisis because of the lack of water, and profound social instability in Africa, particularly in the transient zone of the Sahel. And we will come back to that, how much the migration to Europe is linked to the lack of water in Africa. So all these elements have a strong relation to water. Now if you look at access to water in terms of water supply, and then you have this funny map which shows proportionally how important the lack of access to water is. Then you see that in this map, basically, Europe, Italy doesn't exist in the sense of having problems to access to water. The whole European Union doesn't exist because we have all the water problems solved. North America doesn't exist. But where the big problems are is India and China. And these two are the most populous countries in the world. Is there really a crisis? I think it is a crisis if there are annually 6 to 8 million people who are killed by water. Every single year there are 8,000 children, or every single day 8,000 children are being killed by water or water-related diseases and disasters. 85% of our wastewater, 85% of our wastewater goes untreated into the seas and oceans. And today we will see, this is what is happening in the Mediterranean and also in the Pacific. There is a huge problem with the biodiversity of those seas and also with the plastic solution. We have lost 50% of the freshwater species over the past 30 years. Now, what is this if not a crisis? Superimposed on all this bad news, there is one which is even without, whether we like it or not, is coming. This is the climate change. Now, of course, you have to have it in context. The climate has always been changing the past 4 billion years. If there were no climate change, we would not be sitting here because dinosaurs would be happily walking over here. So climate change had a natural variability. However, ever since the Industrial Revolution, climate change is going up and speeding up, and we will see that in a moment. It has negative impacts. This is in Japan. That's not my photograph. I borrowed it from a friend of mine. It's not a tsunami, but it's a levee topping, overtopping, a flood levee. Because the Japanese rivers are very short and the relief energy is very high, therefore the runoff is extremely speedy. So these flash floods, the Japanese hydrologists have recognized that it seems that they are occurring more and more frequent. And we were wondering, why is that happening? Why is it happening not only in Japan, but also elsewhere in the world? And if you look at the damage that has been caused by all the disasters, this is I have borrowed from the Zurich Reinsurance Company, you see that earthquakes, they are very nasty guys. Our friends in Perugia have experienced it every day. But as compared to the water disaster, they are not in the same league. 90% of the total disasters, both in terms of financial losses and human life losses, they are related to water. Now, indeed, what is happening? What the science is examining is the following question. Is it true that the hydrological cycle is accelerating? Because if it is accelerating, and I'm not going to load you with more science, but the fact is that if it is accelerating, then the probability of the extremes is going up. There will be more floods, but at the same time, to keep continuity at work, there will be more droughts. So the distribution of the extremes in space and time will be changing. Will that mean that we will have less water available? This is not a question. If you look at the statistics over the past 35 years, in the 80-85-ish period, the per capita water availability was 15,000 cubic meter per person per year, grosso modo. Today, it's down to 5,000, with a huge variability, of course. For instance, in Canada, they have 120,000 cubic meter. In Jordan, they have 120. And ever since the influx of the migrants to Jordan, it has gone down to 70 cubic meter per person. This is the amount of water a Californian is using in about 10 days. Now, nobody says that the lifestyle of the Californian lifestyle is sustainable. But these are very severe problems because the cycle is indeed accelerating. If we have time, we will go into the details, but that's the fact is, the sad conclusion is indeed the time of easy water is over. What are the drivers which made this happen? There were a couple of key changes over the last century. While at the beginning of the 20th century, the population was 2 billion human beings, at the end of the 20th century, we had 6 billion. Now, there was 3 times more people at the end of the century at the beginning. However, when it came to water withdrawal by the same people, it increased 6-fold. So there is a gap which is opening up with respect to water usage, and that is clearly not sustainable. there is nothing better perhaps to illustrate it than if you look at the world cities, how they are distributed. They were 60 or 70 years back. There were a few, eight cities where the number of people exceeded 5 million. 60 years later, this is what happened. There is a huge influx of people into urban areas. In 20 years' time, 80% of humanity will be living in cities. This will be a totally new ballgame, not only with respect to access to water, but also social stability. The whole social fabric of an urban megacity will change. So amongst the drivers, there are a few. Global population growth all the way down to climate change. And what is the most important driver? Is it climate change? No. This is the most important driver. Ever since the Homo sapiens is walking around on the earth, if you look at the number of Homo sapiens ever lived, including Moses, Jesus Christ, Muhammad, Stalin, everybody, half of those characters are our contemporaries. Half of the humans ever lived are our contemporaries. This inevitably leads to changes that could be measured globally, and we already are able to measure those things. The big drivers, the 3 Ps, as they say, is population growth. That's the number one driver, which is also a cause of the second driver, which is pollution and poverty. Unless we are able to handle these 3 things and manage it somehow, there's no way but we will have a continued influx of migrants who are running away, either from wars or from rotten political regimes, or for the lack of water. Look at the transient zone in Africa with a high hydrological variability between the Sahara and the Sub-Saharan Africa. For the Sahel, as it is called in Arabic, transition. The farmers have for 11 years they have no water. There's no water, there's no agriculture. There's no agriculture, there's no life subsidy. No life subsidy, they have to move. They're moving to the suburban areas. In Nairobi, there is a bidonville. What is bidonville in English? Slum. A slum, that's right, a slum. Of 2 million people already. And they start moving because they got no jobs in Nairobi. So out of 6 Africans who are migrating, 5 of them are migrating within Africa, and 1 is coming to Africa, to Europe. So this is a huge, huge issue. And of course, migration is strongly linked to climate variability. Ever since our ancestors came out of Kenya 90,000 years ago, we had a number of climate episodes which were forcing people to move. However, over the past 10,000 years, right here, which is a relatively stable climate, which we call the Holocene, here you see down there, the last 50,000 years, this is coming from ice core data, the climate was much, 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 much colder. And then all of a sudden we have this interglacial period between 2 glacializations, the Holocene. But even the Holocene in the upper graph you see, there were changes. Climate optimum, Julius Caesar was lucky because it was warm, so they could have wars and all the rest of it. And then in the 16th century we had the mini ice age, and if you look at the Dutch paintings from those days, the Dutch were happily skating every year because the canals were frozen. Now they can do that only every 14 years because the climate became much, much warmer. So the impacts are as follows: that because of the human population and because of the Industrial Revolution, what we see is an exponential increase in the carbon dioxide release ever since the Industrial Revolution. Ever since we have regular climate observations, and that is not long, 140 years, regular climate observations. Nevertheless, what we see is a growing trend This is observation. This is not a religious question whether it exists or not, whether you believe it or not. These are observations. Ever since the last century, what we see is an increase, exponential increase in the anthropogenic nitrogen fixation. We see an exponential increase in the nitrogen fluxes to coastal zone. We see an exponential increase in the loss of tropical rainforest. We see an exponential increase in the species extension. We see an exponential increase in the number of McDonald's restaurants. So everything seems to be exponential. Therefore, age-old hypothesis upon which generations of engineers were trained, namely that we have a stationary world, is not anymore true. Stationarity, that means that the statistical property of our time series does not change. It is the same average, same standard deviation, same correlation structure, and then we are fine. The problem is that, as we observed and as I have mentioned, we saw that floods are increasing. And in every country, including Italy, there are national standards against which engineers are designing their structures. Bridges, culverts, houses, everything. In rural areas, normally the standard is you design a bridge against a flood that happens once in 100 years. In cities, you design your bridges against floods that occur, statistically speaking, once in 500 years. A few years back, I was in Prague as a UNESCO person to help the big flood in the Czech Republic that has inundated the metro system. So for 6 months there was no metro in Prague. And at a press conference, a journalist asked me, how often does this happen? I said, well, I learned from the Czech hydrologist that this was a 200-year flood that, statistically speaking, occurs once every 200 years. And those journalists are funny guys, so you have to be careful with them. And he said, well, it's all right, but last year we also had a 200-year flood. How is it possible? I said, well, according to the statistical hypothesis what we are making, that the samples are independent, they are not correlated, it could have happened that the last year flood occurred in the last year of the previous 200 years. What we have now is the first of the next 200 years. Statistically speaking, this is okay. And he said, this is all right. But the year before the last one, we also had a 200-year flood again. So science stops. That means that we have to reevaluate all, and this is a big challenge for our science, we have to reevaluate all our design tools and come up with tools that are able to use non-stationarity. Because what happened is that we have entered into a new geological time period, although some of the geologists are still debating about that. But there is a consensus that is emerging that the Anthropocene, the scene or the time epoch where we are living, has changed the world so much that this is a new geological epoch. Everything has changed. Runoff,